Hey everyone, you are watching 100GB and welcome to the 6th episode of the Clean Code series. Today we will talk about the objects and data structures. Well, not the conventional data structures. These are more like data classes. So this series is all about this great book called Clean Code by Robert C. Martin. The purpose of this series is to develop a code sense in all the software engineers around the world so that they, or I should say we, can write better softwares. Let's get right into the video. First, let's talk about data abstraction. What is data abstraction? Well, it can be regarded as an act of keeping everything private or exposing as little as possible. In technical words, it means having a super simple interface but a deep and a complex implementation. Why does data abstraction exist? Why do we even need it? Let's take an example and see where does data abstraction help. Okay, so we have a class here that probably represents a point in the geometry. And it exposes two public variables. One is x and y, of course. It looks fine. And if we take a look at the second class, which is again point, ABS, maybe absolute, I don't know. It's an interface, exposes a few methods to get x and y, get r and theta, set the coordinates in the polar form. Now, if you see the second class or the interface, it is actually more than just a data structure. There are multiple benefits here. One benefit is that we get a controlled access policy. So a point cannot exist without either of the coordinates, that is x and y. And that's why we have only two setters which actually tie x and y together. And in the other one, we tie r and theta together. So setting x and y kind of becomes an atomic operation here. These are setters, but in real world, these can actually be factory methods which actually create the point object. Anyway, the second point is readability. The code is arguably more readable in the sense that the reader need not care about the internal implementation of this class, just the methods. The other thing is the maintainability. The code is more maintainable as well. Well, quite a few times we have reasons to change internal implementations of a class, and in the second case, we can do whatever we want. Like, as long as we maintain the contract, we can change not the behavior, but we can change the implementation. Last but not the least, testing. If we write tests for the first class, we might end up accessing the internal state directly. I mean, x and y are basically exposed. The clients may actually change them on the fly, and because of which the tests will become super brittle. Well, a brittle test is something which fails even with a minimal code change. And trust me, brittle tests are super painful. It's not to be desired. It's good to generally test the behavior of the underlying class instead of accessing the internal state, which is kind of enforced in the second class because everything is methods. Well, another thing that's mentioned in the book is that abstractions can be thought of as a paradigm where we always expose the essence of the data and not the data itself. Like the first case, we are actually exposing the data itself, but in the second case, it's just the essence of the data or all the manipulations and permutations that can happen on top of the data. Okay, next topic we have the data and the object. Anti-symmetry. Okay, here the book talks about the stellar differences between the procedural and the object code. Okay, let's take a look at the code. Okay, in the procedural code, we have a class shape type that represents, it can be regarded as an enum that has three types. And then we have the square class. It has the side. We have the rectangle class, which has the width and height and the getter. And we have circle, which has the radius. And we finally have a shape calculator class, which calculates the area based on the object which is passed. The function is super simple. Lots of if and else conditions, if else ladder as we call it. Checks if it's a square, it's a rectangle, it's a circle, and do stuff. And that's how you use it. You basically call calculate area with the required object and it calculates the area. Now let's take a look at the object-oriented code. We have a shape, like an abstract class shape that defines the blueprint of the shape, which has the calculate area method. Square extends shape, then overrides the calculate area method. Same for rectangle, same for circle. And the implementation is that you create the object, you just call the calculate area method on that appropriate object, and voila. If you see the differences, procedural code makes it easy to add new functions without changing the existing data structures. Okay, so let's say you want to add a new method, which is, let's say, calculate parameter. Okay, so you want to add this new method which calculates the parameter. In the procedural case, you just add a new function here with if and else ladder, and you don't need to change the existing classes. But if you were to do the same for the object-oriented code, you will actually add a new method over here and then implement the same method in every class, which is still kind of fine. The other difference that we have is that the procedural code makes it hard to add new data structures because all the functions must change. Let's take a look at the code. So in procedural code, if you were to add a new shape, let's say you were to add public class my shape, you will actually have to go to every method and then add a new else condition. Like in this case, you will do it for calculate area, you will do it for calculate parameter as well. But if you want to do the same thing with the object-oriented code, things are a little simpler. That you just add a new class, let's say is my shape, extends shape, and you just implement the existing methods over here. So it kind of ties in well with this open close principle where classes should be open for extension but closed for modification. So it's more like that the shape class is open for extension and you have extended it with a new class. That's how things are. Okay, now you would say, okay, Gaurav, we understand this. All books are always filled with these generic examples, which in real life, we hardly encounter. Okay, let's get to the practical aspect. The concern here is partially right, because for someone working on games, game engines, this is something that they encounter on a regular basis. Anyway, let's take a look at the code that is running on 3.3 billion devices, including your phone right now. So we have this very important service inside the Android operating system called Window Manager. So this service actually manages whatever you see on the screen, and internally it maintains this super big tree that contains a lot of elements. And so there are around 10 types of elements that it can have, and an activity record, which is indirectly used by the apps to show UI, is one of them. And what you're looking at right now, the name of the class is window container. So this represents the generic element. Like every 10 types of elements that we have, those are actually 10 different classes. They actually extend this base window container, and it has a lot of common functionality, which most of the classes either override or they use as is. And if you take a look at this class, okay, we can see if it has children. Oh yeah, there we go. It has the children of the same type. It uses a generic type, but if we see, the generic type also extends window container. Okay, so this is a very simple Java file, not a lot of things going on, just 4,000 lines, super easy to understand. Just kidding. Okay, so there you have it. Like Android uses object orientation heavily. Okay, next, let's talk about the law of Demeter. The law says that a method F or a class C should only call 4 types of methods. The first type is methods of the class C itself. The second type is methods of an object held as an instance variable in C. The third one is methods of an object created by F. And the last one is method of an object passed as an argument to this function F. Well, to put it simply, you shouldn't be calling a method on an object returned by calling another method. Let's take a look at the code. So we have this method do stuff in some class that takes in some context variable, and it does this stuff. It calls get options, then get scratch directory, get absolute path. Now the problem here is that you're kind of expanding your code path dependencies, which can make the future changes super hard because you end up depending on more classes. So having said that, it is still fine doing it if these are merely data structures and not the objects with complex stuff. So what to do here? Okay, so the next best thing that can be done here is you can just pass the absolute path directly. Absolute path. And let the caller figure out whatever needs to be done. And you simply get the path. That's how you're not depending on any other class. You just have a string, that's it, because that's what you needed. This original chain can also be broken down like this. So you can have, you can call every method separately, then store the object, call it again, call it again. Now again, this is fine as long as these are simple data classes. And by the way, this kind of code is often called train wreck. Okay, next, let's talk about DTOs or data transfer objects. Those are effectively the data structures we saw in the procedural code. Let's take a look at them again. Okay. So these classes that you saw as part of the procedural code, which is the square class, the rectangle, the circle, these are effectively data transfer objects. These contain just the data and simple setters and getters, that's it. So these are widely used at places where the data needs to be serialized or deserialized, either in and out of a database or in and out of a network. And these are also known as data classes, POJOs, beans, and we also have protocol buffers. Protocol buffers is some specific way of writing these data classes. And with that, we have reached the end. Okay. The conclusion is that whatever class you are writing, it's going to be representing an object, and more precisely a behavior in the form of functions. And you should just try to limit the visibility of these of the instance variables as much as possible. Just limit the visibility of the internal state of the class. And I would love to know your thoughts on the series in the comments below. And before you leave, don't forget to hit that like button. It means a lot. Thank you. Bye.